Hello everyone, welcome to another video. In this video we are going to solve integral sin inverse x dx. To solve this integral we can use integration by parts method. We don't know how to integrate sin inverse x directly, so we can write sin inverse x as 1 into sin inverse x. We know integration of the 1 equal to x. We can write sin inverse x term as it is minus integral x into now differentiation of the sin inverse x. Differentiation of the sin inverse x we can write as 1 over root 1 minus x squared dx. Then we can write x sin inverse x minus x into 1 over, instead of square root value of 1 minus x squared we can write 1 minus x squared to the power of half dx. Now we have x sin inverse x minus integral x into, instead of 1 over 1 minus x squared to the power of half we can write 1 minus x squared to the power of minus half. We know integral fx to the power of n into f dash x, or differentiation of the fx we can write fx to the power of n plus 1 over n plus 1. So in this case 1 minus x squared just like fx minus half just like n. So we need to find differentiation of the 1 minus x squared. Differentiation of the 1 minus x squared equal 0 minus 2x, or just minus 2x. To get minus 2x we can put minus 2 in the numerator, and to cancel out that minus 2 we can write minus 2 in the denominator. Then we can get 1 over minus 2 as a constant value from integral. Then we have fx to the power of n into f dash x. Fx mean 1 minus x squared, n mean minus half, f dash x mean differentiation of the 1 minus x squared or minus 2x value. Then we can write half constant value into fx to the power of n plus 1 over n plus 1. In this case 1 minus x squared minus half plus 1 equal plus half over plus half. Then we can cancel out plus half value. Then we can get final answer as x sin inverse x plus 1 minus x squared to the power of half plus c. Here c is an arbitrary constant.